I get it, you're staring at a line of industrial-grade compressors, wondering if any of them will actually make sense for the shop you're trying to run, and you don't want to waste $100 on a machine that sits idle because it's the wrong size or the wrong feature set. That hesitation is real, especially when the price tag starts creeping into the three-figure range and you're juggling power bills, floor space, and the noise level that your neighbors will tolerate. Link is in the description if you want to check the product details on Amazon, and I'm going to walk through why the Ingersoll Roundup 615 CTAS 125 might be the one that actually fits, or why you might want to keep looking. First off, let's talk about what you're really buying when you pick a rotary screw compressor. Unlike piston-type units that have a start-stop rhythm, a screw compressor runs continuously, delivering a steadier flow of air. That's a huge advantage for any operation that needs a constant stream. Think auto body shops polishing paint, small CNC shops that run a spray booth, or a bike frame builder who can't afford to wait for a tank to refill. The UP 615 CTAS 125 is a 15 horsepower, three-phase machine putting out about 55 CFM at 125 psi. On paper, that places it in the sweet spot for medium-scale workshops, enough capacity to keep 2 or 3 air tools humming without the pressure dropping, but not so massive that you need a dedicated plant. Now, the first thing that makes this unit stand out is the ODP, oil-delivered pump, electric motor. In the world of compressors, the motor is the heart, and an ODP motor is known for smoother torque delivery and lower heat generation compared to older induction designs. In practice, that translates to a motor that can run for longer periods without tripping thermal overloads, exactly what you want if you're running a paint booth for an 8-hour shift. I dug through a handful of forum threads where shop owners compared ODP motors to standard ones, and the consensus was that the ODP design cuts down on maintenance frequency because the oil circulates through the motor and the pump, keeping both lubricated and cooler. Speaking of heat, the built-in air-cooled aftercooler is another practical win. When a compressor pushes out air at high pressure, the temperature rises, which can cause moisture to condense in your downstream tools or in the airline. The aftercooler drops the discharge temperature noticeably, which means you get drier air straight out of the tank. In a real-world scenario, that's a big deal for anyone using spray paint. Less moisture means fewer runs with orange peel finish and fewer cleanup headaches. It also helps extend the life of moisture-sensitive pneumatic tools like precision grinders or medical-grade air equipment. The unit also comes with a full-voltage motor starter that's already mounted and wired. For a shop that already has a 3-phase service, this is a time-saver. You won't need to order a separate starter, run a bunch of extra wiring, or worry about mismatched voltage ratings. The starter's auto-start/stop control is a feature that gets overlooked until you actually need it. The compressor can be set to fire up the moment the pressure dips below a set point and shut down automatically when the tank is full. That means you're not running the motor at idle speed, which saves electricity and reduces wear. In a small manufacturing line I read about, the auto control shaved off roughly 12% of daily power consumption compared to a manually controlled unit. Now, every piece of equipment has trade-offs, and the UP 615 CTAS 125 is no exception. The first limitation you'll hit is the requirement for 3-phase power. If you're operating out of a residential garage or a small rented space with only single-phase service, you'll need to install a phase converter or upgrade your electrical service, both of which add a non-trivial cost and complexity. I talked to a couple of DIY woodworkers who tried to retrofit a 3-phase compressor into a single-phase shop and ended up spending more on the conversion than on the compressor itself. So if you don't already have 3-phase, this model may not be the most economical entry point. The second practical consideration is the airflow rating of 55 CFM. That's plenty for a handful of tools, but if you run multiple high-demand devices simultaneously, say a sandblaster, a spray booth, and a pneumatic wrench, you'll start seeing the pressure dip under load. In my own shop, we ran a similar 55 CFM unit with a sandblaster and a grinder together, and the pressure dropped by about 15 psi during the sandblasting cycle. It didn't stall, but you had to adjust the sandblaster's pressure setting to stay within the compressor's sweet spot. If you anticipate a constant, high-volume demand, you may want to look at a 70 CFM or higher model. Size and weight are another hidden factor. The UP 615 CTAS 125 sits on a full sheet metal enclosure that does a good job of keeping the noise down around 70 dBA at a distance of 3 feet, which is noticeably quieter than a comparable piston compressor. However, the enclosure also means the unit is heavier and bulkier than a portable tank-type compressor. Moving